Hello, boys and girls. We are on chapter 13, lesson 2, and it's all about area. And I bet in class you talked a lot about what area was today, right? Do you see how these two rectangles are shaded in gray? All of that gray space is the area. Now, the other day we talked about perimeter. And the perimeter, remember, is just the line, the distance around. The area of a figure is how many square units fill it up. Area is all about square units filling it. Okay, so the directions for number 5 and number 6 say find the area of the rectangle or square. So this rectangle, they've put it kind of an unusual angle, but that's okay. We still find area the exact same way. So it says that the width is 5 centimeters. That's how wide it is. And it's 30 centimeters long. Okay, now remember in 3rd grade when you were first learning how to multiply, you talked a lot about arrays, which are, you would have stuff like this. Okay, so this would be an array that's 3 rows of 4 circles. Yeah, these are supposed to be circles. There we go. 3 rows of 4 circles. How many circles are in 3 rows of 4? 3 rows of 4. It's 12 circles. It's the same idea with area, except we're talking about square units. So in this one, it's square centimeters. And they are literally talking about squares that are 1 centimeter on each side. So for number 5, we have 5 rows of 30 centimeters. What's 5 rows of 30? 5 rows of 30 centimeters. Well, right? You know what 5 times 3 is? 15. And then ka-ching, that's not just 3 though, it's 30. So let's make that 10 times bigger. So it would take 150 of those 1 square centimeters to fill this rectangle. Its area is 150 square centimeters. All right, let's look at number 6 now. This rectangle is 4 feet wide and 14 feet long. So if you just think about an array again, you think of this as feet. Each square that's in this rectangle is 1 foot on each side. So you have 4 rows of 14 feet. So how many of these square units makes that rectangle? Well, I'm going to have to write this one this way. 14 in each row of 4 rows. Okay? And your teacher may have given you this idea. Area equals length times width. Or, of course, width times length. But that's how most people say it. Okay? So 4 times 4 is 16. 16. 4 times 1 is 4. Plus 1 is 5. So this rectangle is 56 square feet. Okay, it's a square that's literally 1 foot long on each side. All right, beautiful. Okay, so this is near the bottom. Number 8. Bryson is laying down sod in his yard to grow a new lawn. Each piece of sod is a 1 foot by 1 foot square. It's exactly what we were just talking about. Each piece of sod is a square That's 1 foot long on each side. How many pieces of sod will Bryson need to cover his yard if his yard measures 30 feet by 14 feet? Now, do you know what that by means? 30 feet is one dimension and the other dimension is 14 feet. I'm going to make this a green rectangle since it's talking about his yard, right? So we're going to make this short side and a long side. You can draw it the other way if you want to. Okay, so let's label this 14 feet. And then this is 30 feet. And it's filled with squares. And when you find area, you find out how many squares it's going to take to cover Bryson's lawn. How many of these little grassy squares? Okay, so when they say 30 by 14, they just mean 30 length, 14 width. Okay, so we have 14 rows of 30. So again, 14 rows of 30 squares. Let's see the best way to multiply this. Well, there are a couple of ways we can do it. Let's do it this way. 30 times 14. How does that look? Pretty good? All right. 4 times 0 is 0. 4 times 3 is 12. Okay? We're done with that ones place. We're going to put a 0 in the ones place because we won't have any more ones times ones. We're going to move over to the tens. 1 times 0, 0. 1 times 3 is 3. We're going to add these two partial products. 0, 2, 3 plus 1 is 4. So the Bryson will need 420 square feet. Let me see how they asked it though. How many pieces of sod? 420 pieces. Okay? And each piece, of course, will be 1 foot on each side. He's going to need 420 of those. Goodness, I hope he has a big truck or something. All right, now we're on the back. Ellie and Heather drew floor models of their living rooms. Okay, floor models of their living rooms. So they drew models as if they were looking down onto the floor of their living room. Okay, like they're up on the ceiling looking down. And you would say like, oh, here's where my sofa goes. There's the TV. There's a little rocking chair. There's the doorway. You know, like we're looking down from the sky. That's what the floor model is. So Ellie's model represented 20 feet by 15 feet. Okay, so Ellie's model, 20 by 15 feet. Heather's model represented 18 by 18 feet. Oh, so Ellie, what kind of shape is her living room? If it's 18 by 18, that's right, it's a perfect square, isn't it? 18 by 18. Whose floor model represents the greater area? How much greater? Well, this is a two-parter, huh? Okay, well, I have to label some things here. Ellie's model. So this is Ellie, and then this is Heather's, right? Because we don't want to get mixed up. I just like to be organized. So Ellie's model is 15 by 20. So let's do 20 times 15 and see what the area is. 5 times 0 is 0. 5 times 2 is 10. Placeholder, because we're done with that zeros place. 1 times 0 is 0. 1 times 2 is 2. Add those two partial products. 300 square feet. is the area of Ellie's living room. Now, Heather's living room is 18 by 18. Okay, I'm going to do that math right here. 18 rows of 18, okay, to find how many square feet are in her living room. Okay, 8 times 8. Well, you guys remember that one? 8 times 8. If you don't, go back to 8 times 5 is 40. 8 times 6 is 48, right? Okay, 8 times 8 is 64. 8 times 1 is 8, plus those 6 more. So 8, 9, 10, 11, 12, 13, 14. Okay, got a placeholder. We're done with you ones. So we move over to the tens. 1 times 8 is 8, and 1 times 1 is 1. Let's add those two partial products. 4, 8, 9, 10, 11, 12. 1, 2, 3. So the area of Heather's living room is 324 square feet. Okay, so now we have the two areas. It says, we have to go back and, sometimes you don't even remember the question. You've done so much math. Whose floor model represents the greater area? Well, we're comparing 300 square feet to 324 square feet. So remember we labeled that? That's right, Heather's. Okay, so Heather's is greater. So we can say no to A and no to C. Okay, so then the two choices that say Heather, this one says Heather 24 square feet, Heather 324 square feet. Well, I better go back and reread the second question. How much greater is the second question? So does the second question say, what is the area of Heather's living room? No, it doesn't. It says, how much greater is Heather's living room? They want to know the difference between Heather's and Ellie's living room. So how do we find the difference between them? 324 minus 300. We subtract the two areas. That's mental math right there, isn't it, boys and girls? So is the answer B, 24 square feet, or D, 324 square feet? Well, they said how much greater? It's 24 square feet greater. Okay? Nice work, guys. That was kind of like a 3-part question, wasn't it? But you persevered. All right, now we are on to review Chapter 3, Lesson 5. It says that each of the 28 students in Rami's class raised at least $25 during the jump-a-thon. Oh, that's like we have a read-a-thon at our school. They have a jump-a-thon. What is the least amount of money the class raised? So they're saying that each student raised at least $25. So some may have raised more than that, but all of them raised at least $25. So 28 students raised at least $25 each. So remember, when you have the same amount again and again and again, we can repeatedly add it, or we can multiply it, right? So there are 28 students who each raised $25. So we have 28 piles of $25. 28 students each raised $25. Okay, so 5 times 8 is 40. 5 times 2 is 10, and then we have to add on that set of 10 that we just regrouped. So that's 14, right? 10 plus 4. We have our placeholder there. We are done multiplying ones times ones, so we have a placeholder there. So we go to the tens. 2 times 8 is 16. 2 times 2 is 4, plus 1 more is 5. All right? So guys, just looking at those two partial products, are there a couple of choices that right now we can eliminate? Definitely choice A, right? That's not going to add up to $5,200. And definitely choice D, because it's way more than $196. All right, now let's add them up. 0, of course. 6 plus 4 is 10. And then 5, 6, 7. Oh, that's a nice number. So Rami's class raised $700 for the Jump-a-thon. All right, great job. Guys, you're awesome. Have a great night, and I will see you soon.